So this presentation is going to be all about how do we control runoff and why. Here are the key vocabulary terms and the concepts that you should understand or have in your notes to be able to be successful on the notes quiz at the end of this presentation.
So here we've got precipitation. And remember that water from precipitation does one of two things when it hits the ground. It either infiltrates, goes into the ground and becomes part of groundwater, or it moves across the surface as runoff water, which is any water that doesn't infiltrate and moves across the surface. The question becomes, how much of all of this water is going to infiltrate and how much is going to become runoff? And that's determined by a couple factors. One of the most important factors is, what is the ground like? Natural ground allows for a lot of infiltration. Something like that, a lot of water can go into the ground because there's nothing to stop it. The problem is roads and sidewalks and buildings. Those are impervious surfaces. An impervious surface is anything that water cannot go through to get to the ground. So that would be a pervious surface, the natural surface. That is an impervious surface. Impervious surfaces make all of the rain that falls become runoff. As you can see by this roof here, every drop of water that hits this roof is just running off, and it's going to go somewhere. As opposed to that surface right there. You notice you don't see any water running out of the pine straw because the water there is able to infiltrate. About 90% of the water that hits a natural surface will go into the ground. 100% of the water that hits an impervious surface is going to run off and going to go somewhere else. And the problem becomes all of that water from our impervious surfaces has got to go somewhere because we are now not letting that water go into the ground naturally. So we have disrupted that natural flow of water in the water cycle. The next step to this equation is, well, what do we do with all of that extra runoff out there? Where does it go? And how do we handle it so that it doesn't cause flooding somewhere else?
So that's the whole purpose of this presentation, is what happens to that extra runoff water? What do we do with it? And how do we keep it from causing us problems? Consider this aerial view of the Centennial High School area. And all of this area in here used to be nice trees, natural surfaces. So when the water hit there, it just went into the ground. Well, now we've covered it with parking lots and buildings. So now much more water becomes runoff. And where's it going to go? I want you to think about this area and where's the low point? Probably over here, the intersection of Eves Road and Holcomb Bridge Road. That's kind of the lowest point in this picture. So all my water is going to try to run off and go to the lowest point. Well, why is that bad? If all the water winds up down there at the corner of Eves Road and Holcomb Bridge, I could have something like this. The water's going to go down there to the low point of the road, and I can't have this. I can't drive through it. I can't have a lake in the middle of my intersection. So the runoff has to be managed. We have to do something with it so we don't have problems like this. So how do we manage it? That's the point of this presentation. So where does the storm drain water go? Well, the easiest thing to do with it is to take it straight to the river, because most runoff's going to want to go to a river anyway. Now, it's okay for runoff water to make it into the river because it's clean. It's just precipitation. It's the same as the runoff water that would naturally flow into a river. This is why with the storm drains, you'll see things like this that have little stickers that don't dump, because anything that goes into that storm drain could possibly wind up in the river, and we don't want pollution and trash to pollute our river. You should never pour anything down a storm drain like these chemicals, because that could wind up in the river and just pollute the river water. Now with storm drains, you got to be careful that you don't allow things like dirt and leaves and trash to build up, because then they block the storm drains, and the storm drains can't move the water that we need them to move. So that means the water stays on the street and can cause something like this. Typically, you'll see this along the interstates in a really, really heavy rainstorm, that it'll start to flood. And the reason for that is the storm drain got clogged with a bunch of the trash that we find typically beside our highways. Now, we can't send all of our runoff to the rivers, because the rivers and streams can't hold all of the unnatural runoff that we made. A river can't hold an infinite amount of water. So you'll get this happening. Here's my river, and it naturally carries water. But if I allow too much extra water to come into the river, it's going to come out of the river. The river can't hold that much. And we have a situation that is called a flood. A flood, by definition, is just when surface water escapes where it normally naturally flows. And you can see here is the natural river. We don't usually have water over here. And generally this is caused by too much runoff being allowed to go into a river. So we can't put all the excess runoff water into a river even though it's clean. Where can we put it so we don't have flooding problems?
So this here is an example of a retention pond that we actually have here on Centennial's campus. And the story behind this goes is this part of the building here, the J100 Hall, was added onto the school later. And when the school board went to get permission to build this, well, the city of Roswell said, you've got a lot more impervious surfaces now, which is going to cause more runoff. What are you going to do with it? And they had to come up with a plan. And the plan was, we'll take the water off of the roof and we'll dump it into this little holding area here so that it doesn't end up going down the street and eventually to the Chattahoochee River. Well, what's the water do when it gets here? Remember, it either infiltrates into the ground or it will evaporate up into the sky. And we've actually got some plants in there to actually help drink up some of the water and put it back in the air. So once again, this is an example of a retention pond that we have right here on Centennial's campus to help manage the extra runoff water when we build new parts to the school. All right, what you're looking at here is the main retention pond for Centennial High School. And this retention pond was put in 1997 when they built the school as a place for all the excess runoff water off the building and the parking lots to go. So up there is the tennis courts and the rest of the school, and over there is the practice field. And every storm drain from the main part of the campus leads to this point right here. And the water after a rainstorm will come out and wind up over there in the retention pond. Now you can see the size of this area. It's pretty big. There's a lot of wasted space here on our campus that we have to allow just as a place for excess stormwater to go.
So any building is going to create runoff. And in a place like Roswell, we have to manage the runoff because we can't let it go to the river and flood. So most buildings will have some place like a retention pond to hold on to excess water.
So what you see back here behind me is called Martin's Lake, which is the big lake in the middle of the Martin's Landing subdivision right close to the school. And this is a really, really, really big neighborhood with lots of houses and lots of roads and lots of other buildings. And when they built this and they put in all these houses, they created a lot of extra runoff. And as we've talked about before, you've got to have a plan to manage that extra runoff. And here's what they did. They ran it all into this area here. So basically, this Martin's Lake is just a really big, fancy retention pond. As a matter of fact, most of the ponds and lakes that we have in our local neighborhoods are nothing more than fancy retention ponds. Because before this neighborhood was built, this was all woods and trees and plants, and the water would have infiltrated the ground. Well, once they built the houses and the streets and the roads and the parking lots, all of that extra runoff was going to end up going that way, which is where the Chattahoochee River is. Now you can imagine if all of this extra water wound up in the river, we would have a lot of really serious flooding problems. So once again, retention ponds are built to hold excess runoff water.
Most of the ponds, most of the lakes in our area are not natural. They are actually retention ponds that were put in when they built the new neighborhood to handle all of the runoff caused by the new roads and houses and buildings. So any developed area, any place that has some man-made impervious surfaces has to have something to help manage the runoff.
So here I am outside of Tampa, Florida, and you know it rains a lot in Florida. Well, if you look at this area that I'm in, there's some big parking lots and sidewalks and big roads and buildings with lots of impervious surfaces. So when all that rain hits the ground, it is going to run off. And the question becomes, what do you do with it? Well, in Georgia, we would run all of that excess water into a storm drain and carry it to a retention pond and let it hang out there. Well, in Florida, they do something a little bit different. What you see in this picture is just a big, huge drainage ditch right beside the road. And what happens is the water just goes in that drainage ditch and it's allowed just to sit right there. And you can see it sitting right there. The reason they can do this in Florida is because the ground is so sandy. This ground is almost entirely sand. And as you know, water goes through sand very easily. So all of this water is eventually going to drain right into the ground Or on a nice sunny day where it's hot like it is in Florida, the water's going to evaporate. Either way, the water kind of takes care of itself. Now, we can't do this in Georgia because our ground is primarily made of clay, and our ground is really, really steep. So the water is going to run off someplace else. It's going to go to that lowest point. Well, in Florida, every place is pretty much the same low point, so the water can just sit in place. In Florida, it can infiltrate into the ground, whereas in Georgia, with all of this being clay, the water would just sit there forever. And then the next time it rains, more water would be on top of the old water, and before you know it, we've got a little mini flood, and my road is flooded. So in Florida, typically, they're going to use things like drainage ditches a lot more than they would use storm drains, because the water infiltrates the ground so easily because of the sandy soil.
So here's an example. You walk up and down the street in Florida and you won't see as many storm drains up and down the street. In Georgia, you wouldn't have a street. You couldn't go that far up and down the street without seeing some place for the water to go in. But in Florida, drainage ditches work better. Now, in Georgia or in other places, you can use drainage ditches in places where you don't have that much runoff, say in the country. Because notice here, there aren't a whole lot of buildings, and the road isn't very big, so you're not going to have as much runoff, which means a drainage ditch would work okay. You're not going to see them in the city where you have too much extra runoff to manage. We do have one here on Centennial's campus, and it's interesting where it is. Notice it's over here beside the stadium and the baseball field, places where there's a lot more natural surfaces like the grass in the field or the grass here beside the weight room. You wouldn't put a drainage ditch up by the parking lot, but you can put it someplace like beside the grassy areas where the runoff isn't as much to handle. Now there's some very distinct disadvantages to retention ponds, drainage ditches that I alluded to earlier. First and foremost, number one is their size. Look how big these things are. You got to set aside a lot of land to hold all that water. If you look in this picture over here, this is in South Florida where they get a lot of rain, and think every single building here, all the water is going to rain and run off. You got to have a really big spot to hold all that water. So retention ponds are kind of a big waste of space. The second disadvantage to retention ponds is they're kind of dirty and yucky. You wind up with a bunch of trash in there, or when they dry up, say if it doesn't rain for a while, you wind up with a big kind of ugly looking mud pit. So retention ponds are not pretty. They can smell and they can look bad. The third disadvantage to retention ponds is they fill up with dirt and trash and leaves, and when they do fill up, they won't hold their water. So you have to periodically go and dig out retention ponds to make sure they have enough space to hold the water that you need them to hold. Now, there are some alternatives to retention ponds that we're going to look at now.
So here we've got a big shopping center, which is a big building, big parking lot, and every drop of rain that's going to fall on that building or this parking lot is going to become runoff because it cannot get through this surface into the ground. Remember that buildings and parking lots are what we call impervious surfaces that water can't get through to get into the ground. Well, all of this extra runoff has to go somewhere, and it has to be managed. Well, most of that runoff we're going to run into something like this called a storm drain, and we're going to run it through a pipe, and we're going to take that storm water somewhere and have to hold on to it so that it doesn't get into the river and cause flooding. Usually that's a retention pond. The problem with this is I got to build a pipe from here, and I got to allow some land for a retention pond. I got to hold on to that water for a long time. Well, this Target shopping center is trying something new and different, a little bit better alternative to building storm drains. So what they've done is build what's called a bioswale. A bioswale is a low-lying area that's filled with plants that allows for the absorption and infiltration of precipitation. Now the water still hits this parking lot, but it runs off, and instead of going into a storm drain, you see it's allowed to go through this opening here, and it goes into this low-lying area. And you see we've got some trees and we've got some plants here. And two things happen to this water. It either goes into the ground as infiltration, which is what it would have done before we built the parking lot, or these plants are going to help soak up the water through their leaves from the soil, and the water is then going to go back up into the sky via evaporation. So once again, this is called a bioswale. A bioswale is a low-lying area filled with plants that helps in managing excess runoff. So this is the new band room at Centennial, and this part of the building was added on after the school was originally built in 1997. And when the school board went to the city of Roswell and said, hey, we want to build this new building, give us permission to build it, one of the first things the city of Roswell said was, well, what are you going to do with the extra runoff? Because this is a building, and all the water that hits that building is now going to become runoff. What are you going to do with it? Well, here's what was done. Originally, these were all parking spaces in here. But in order to handle the extra runoff that was caused by the new building, the construction company and the school board agreed to put in this little low-lying area here and fill it full of plants. And when it rains, the water is going to go in there and it's going to hang out in this area. And it will either infiltrate the ground or the plants drink it up and release it into the air. So this is an example of a bioswale that we had to put in on our campus when we built the new building that would have caused extra runoff. And the city of Roswell is very proactive about making you do stuff like this in order to handle the extra runoff from new construction.
So here's the bioswale after a rainstorm, and you can see it works. A bunch of water runs off of the parking lot, and all of the water in here is going to either be drank up by the plants and put in the atmosphere. It's going to sink into the ground via infiltration, and either way, that's water that stays out of the Chattahoochee River and therefore makes it less likely for us to have floods.
Well, more recently than building the new band room was this addition that was put onto the front of the school, this extra little portico or lobby. And to build it, you had to get a building permit. You went to the city of Roswell and said, hey, we want to build this new part to the school. It's a little bit more roof, so there's a little bit more runoff. And the city of Roswell said, okay, you can build it, but show us a plan that you have to manage some extra runoff. And here's what the builder and the school system agreed to do. They made this little low-lying area here. They dug this out in the front of the school. This didn't used to be here. And you can see what happens. Water will run off the parking lot, which is an impervious surface, and comes down and hangs out in here. All of the water that runs off the parking lot and comes in here doesn't wind up in the river. It won't cause flooding. So this is an example of how you can manage some excess runoff water, and it is required.
So all of these things are options that we can do to control the runoff once we have the runoff. But what if we can make there be less runoff in the first place? Then we wouldn't have to do all that stuff. Well, we can't make it rain less, but let's look at another option. What if we can make there actually be less runoff? Take the same amount of rain, and instead of allowing a bunch of it to become runoff, what if we can let it infiltrate first?
Okay, so here we've got a CVS, a building, and we've got a big parking lot, which are nothing more than impervious surfaces. And every time rain comes down out of the sky, it hits these surfaces and it has to go somewhere because it can't get into the ground. Most cases, it goes into that storm drain and we have to take it somewhere and hold on to it so it doesn't cause flooding in the river. Well, now this CVS did something a little bit different with their parking lot to help manage the excess runoff caused by the building in the parking lot. And they built this right here. They made part of their parking lot what's called a permeable parking lot. Permeable, remember, it means that it allows water to go into the ground. And you can see this, that it's got the ground in between these pavers. So when it rains over here, the water can get back into the ground and infiltrate instead of becoming runoff. So this is another way that we can help manage excess runoff. It's by making what we call porous or permeable pavement, which allows water to infiltrate the ground and lessens the amount of runoff that we have to manage. So let's look at something else that can be done that will help allow water to infiltrate the ground, whereas it might have normally become runoff that we would have to manage with retention ponds and storm drains. So how can we lessen the actual amount of water that becomes runoff? Well, you can use something like this. This is an example of a material called a porous or a permeable paver. You see those terms interchangeably, and although they mean different things, they work the same way when managing runoff. Something that is porous has a lot of open spaces in it, and something that is permeable will allow water to go through it. So here's a material that they can actually use to pave a surface, as opposed to regular asphalt or concrete, which is an entirely solid material. You'll notice this has a lot of open spaces in it. So when it rains and water hits this, the water can kind of hang out in the open spaces in between. That means less water runs across the surface, and that's less water that we have to manage somehow. So that's an example of what we call a porous paver. You can also call these a permeable paver because water will move through them very easily. Something like this. And you can see almost as fast as I pour the water into it, the water goes through it. So this would be water that then is now allowed to go into the ground as opposed to becoming runoff that I have to manage. So this is a good solution as to how we can make less runoff. Now, there are limitations with this. You can see it's not a very solid material, which means that it can't be used everywhere. We can't pave a road with this stuff because a big heavy truck or cars that move very fast are going to squish it too quickly and break it down. Good applications of stuff like this are places where you don't get a lot of heavy use. Your driveway or a parking lot, especially a parking lot that's not used every day. Something, say, like church on Sunday, where you only have cars, and not big trucks, but you only have cars that use the surface about once a week. So think about the size of a church parking lot and how much of the water would become runoff that the church would then have to build a retention pond for or a storm drain system. If you have something like this is going to allow the water to go directly into the ground like it would have naturally, and it's less water, less runoff water that you have to manage and fool with.
So here's an example of how this works. I found this at a brand new Wendy's restaurant in Covington, Georgia. And you notice over here we've got the traditional asphalt, which is impervious. And they paved their parking spots with what's called porous concrete or permeable pavers. And I conducted a little experiment where I went and I got 2 cups of water and I poured a cup of water on the asphalt and I poured a cup of water on the porous concrete. And you can see what happened. The asphalt, the water just runs off because none of the water can go into the material. But over here, you'll notice none of the water started to move off because it's all infiltrating, because that porous concrete has a lot of space and the water can go in it and through it and get back into the ground. Same concept here. You pave this section of the parking lot with regular asphalt and you allow the water when it rains to come over into this surface, which is just nothing more than loose gravel, and the water can go through that gravel and get into the ground. Now let's talk about our houses. So our houses are going to make a lot of runoff because we don't want water coming down through our house and into where we live. Most of the time, our runoff from our houses, we run it to the street, which then has to go into a storm drain, and we got to take it somewhere. An option that you can do, and this is being explored a lot more now, and you can actually get a home credit for doing this, is take the downspout from the house. And instead of running the water into the street, you bury the downspout throughout the yard so that then when the water comes off of the house, it actually is already in the ground. And there's some advantages to doing this. Makes less runoff we have to manage. It can be a way that you water the ground without having to use sprinklers. Now, places where it's sandy, works better than places where we have too much clay. But it's another way that you can manage runoff, and that is you take your downspouts and you put the water straight to the ground. In some cases, you'll put those downspouts into what we call a rain barrel. A rain barrel is another way to manage excess runoff. This is where you collect runoff right there at the house and you hold on to the water to use it for something else, typically like watering your lawn, because your lawn needs the water and it's not going to rain every day. So this is a way for you to hold on to excess runoff for when you need it. Some more advanced methods is they can take the water off the downspout and they actually put it into a tank and they pump that water back into the house, and you use that water to flush your toilet. You generally can't use it to drink, but you can use it for what's called gray water applications like washing dishes or washing clothes or flushing toilets. And this is a way to minimize excess runoff, and it keeps your water bill down because you're using that natural precipitation, which you can do because it's clean water. Coming back to green roofs, remember that green roofs we studied in the fall, that you take a building and you cover it with plants or trees. Well, we know that helps keep the buildings a little bit cooler. Also keeps the cities a little bit cooler. But with stormwater runoff, when water hits these buildings, well, there's dirt up there. And there's plants up there that soak up the water and release the water back up into the atmosphere so that less water comes off of the building, and therefore you have less storm water to manage. So green roofs have another advantage besides just temperature. They help reduce the amount of runoff from a building. So at this time, you can finish your notes, bring them to me for a done stamp, and use them to take the notes quiz for today.